one yourself. Here's where things get exciting, because building a nickel-iron battery doesn't require a shopping spree at some specialty electronics store or a chemistry degree. In fact, you probably have most of what you need already, or you can find it at your local hardware store or online for a fraction of what you'd spend on a new lithium battery. Let's break it down. The core ingredients are nickel, iron, and potassium hydroxide. That's it. No rare earths, no toxic waste, just simple chemistry. For the nickel, you can use nickel-plated steel strips or even repurposed nickel coins depending on your location. Iron is even easier. Steel wool, iron nails, or scrap iron plates all work perfectly. Potassium hydroxide, also known as lye, is commonly used in soap making and can be found in many hardware stores or online. You'll also need distilled water, which is cheap and widely available, and a non-reactive container. Think glass jars or plastic tubs. As for tools, you'll need basic safety gear like gloves and goggles, a drill or punch for making holes in your metal plates, and some wire for connections. That's it. No need for expensive electronics, no hazardous chemicals that require special disposal, and no complicated assembly lines. This is DIY at its purest, accessible, affordable, and safe when handled with common sense. Forget what you've heard about batteries being mysterious or dangerous to make. The nickel-iron battery is proof that powerful, long-lasting energy storage doesn't have to be out of reach. With just a handful of everyday materials, you're ready to build something that can outlast almost anything else on your shelf. Ready to get your hands dirty? If you can follow a recipe, you can build this battery. I'll walk you through every step, so don't blink. You'll want to see how simple and satisfying this process really is. Let's get started. Step 1. Gather your materials. First, lay out everything you need. Nickel-plated steel strips or nickel coins, iron nails or steel wool, potassium hydroxide, lye, distilled water, a non-reactive container like a glass jar or sturdy plastic tub, insulated wire, gloves, and safety goggles. Double-check your workspace is well ventilated and free from clutter. Safety first. Potassium hydroxide is caustic, so always wear gloves and goggles when handling it. Prepare the electrodes.
Years, Roundup was part of everyday life in agriculture, but now studies show that long-term exposure to its...
Step 2. Prepare the electrodes. Cut your nickel and iron materials into strips or plates that will fit comfortably inside your container. If you're using steel wool for the iron, compress it into a tight bundle. For nickel, nickel-plated steel strips work best, but coins can be stacked and connected with wire. Drill or punch small holes in the top of each strip to attach your wires later. Clean the metal surfaces with sandpaper or a wire brush to remove any oxidation. This ensures good electrical contact. Step 3. Assemble the electrode packs. Take your iron and nickel strips and keep them separated. Never let them touch directly, or you'll short-circuit your battery. Use plastic spacers, rubber bands, or even folded paper to keep the electrodes apart. Place the iron and nickel packs into your container, alternating them so each nickel strip is next to an iron strip, but not touching. Secure them in place so they won't shift around. Step 4. Mix the electrolyte. Now, carefully prepare your electrolyte. In a well-ventilated area, slowly add potassium hydroxide to distilled water. Never the other way around, as adding water to lye can cause dangerous splashing. Stir gently until the lye is fully dissolved. For a small battery, a solution of about 20% potassium hydroxide by weight works well. Always handle this step with care and keep the solution away from children and pets. Step 5. Fill the container. Pour the potassium hydroxide solution into your container, covering the electrodes completely but leaving some space at the top. The electrolyte should submerge the metal strips without overflowing. Double check that your electrodes are still separated and not touching. Step 6. Connect the wires. Attach insulated wires to the tops of your nickel and iron electrodes. The nickel side will be your positive terminal, and the iron side, your negative. Use alligator clips or solder the wires for a secure connection. Make sure the wires are long enough to reach outside the container without dipping into the electrolyte. Step 7. Seal and label. If your container has a lid, drill small holes for the wires and seal around them with silicone or hot glue to prevent leaks and evaporation. Label the positive and negative terminals clearly. If you're using a glass jar, you can simply rest the lid on top, but don't seal it airtight. Nickel-iron batteries produce a small amount of hydrogen gas during charging, so some ventilation is necessary. Step 8. Initial charge. Your battery is now assembled, but it needs an initial charge to activate the chemistry. Connect the terminals to a low-voltage DC power source, like a solar panel or a trickle charger, and let it charge slowly for 24 to 48 hours. You'll notice bubbles forming. That's normal and shows the battery is working. After the initial charge, your battery is ready for use. Troubleshooting. Tips. If your battery isn't holding a charge, double check that the electrodes aren't touching and that your connections are secure. If you see corrosion or discoloration, clean the terminals and replace the electrolyte if needed. Remember, nickel-iron batteries actually improve with use. The more cycles, the better they perform. And there you have it. A long-life, rugged battery built with your own hands. No rare materials, no high-tech wizardry, just simple, powerful DIY energy storage. Now comes the moment of truth. Let's see what this homemade nickel-iron battery can really do. Watch as we put this battery to the test, live, with no tricks or edits. First, let's grab a simple multimeter and measure the voltage. You should see a reading between 1.2 and 1.4 volts per cell, which is right in line with what you'd expect from a standard rechargeable battery. But the real test isn't just about numbers, it's about performance. Let's hook up a small LED light. Instantly it powers on, drawing steady current from our DIY battery. Next, let's try a small fan, and again, it runs smoothly. Now, for a side-by-side comparison, we'll take a store-bought alkaline battery and run the same devices. At first, the performance is similar, but here's where the nickel-iron battery pulls ahead. After repeated recharge cycles, the store-bought battery starts to fade, losing capacity and eventually dying. Meanwhile, our nickel-iron battery keeps going cycle after cycle, barely losing any power. Even after dozens of discharges and recharges, the homemade battery holds strong. In fact, nickel-iron batteries are famous for getting better with age. The more you use them, the more efficient they become. So, while most batteries are headed for the landfill after a year or two, your DIY powerhouse just keeps delivering. See how it stacks up against the batteries you're used to? This isn't just a science project, it's a real working solution you can rely on. So, if nickel-iron batteries are so tough, reliable, and easy to make, why aren't they everywhere? Why don't we see them powering our phones, cars, or even our homes? The answer isn't about performance, it's about profit. Think about it. Why would companies sell you a battery that never dies? The business model of most battery manufacturers relies on planned obsolescence. They want you to keep buying replacements year after year, device after device.